Ah, yes. Task scheduling. What a subject. Linux operating system does task scheduling really well. I don't know, it'd be nice if we could compare Linux task scheduling to Windows task scheduling, but guess what? Windows isn't an open system, so I can't get down in there and actually compare the differences. Personally, I think Linux is going to come out ahead. But anyway, I digress. What I want to do in this one is show the details of task scheduling and get as far as we can in a length of time that someone would be able to watch the video or I would be able to create a video. So, here we go. We're going to start with a function called, let me check my notes, tick handle periodic, which is kind of where I left off on the last video. And let's see what else. Tick periodic kicks off. I'm sorry. Tick handle. I'm sorry. Tick handle periodic takes off and calls tick periodic, and tick periodic calls update process times, and update process times calls scheduler tick. So you see, we had to go through some other stuff before we actually did the scheduler piece that happens on each clock interrupt. And then let's see what happens next. Scheduler tick calls task tick fair. Now, in that last video, I got to the point where I was in scheduler tick, but I couldn't find task tick. That's because task tick was buried into this thing called a class where all the specifics of that scheduling type is in there. Now, completely fair scheduling is the best one that's used now. So that class, of course, is in there. But if you want to choose to change it to different types of scheduling, then you can use a different class. So, anyway, I digress again. Let's talk about task tick fair. That's kind of the build, that's really the starting point of this one if compared to the last one. So, task tick fair, what does that call? That calls this thing called entity tick. Entity, not sure why they call it entity tick, but it's probably has some reason. Maybe we can figure it out, but who cares right now or we get lost in the details. Entity tick calls check preempt tick. Preempt tick. Preempt means you're preempting something. That's what scheduling is about is do we want to switch tasks or not? Do we want to stay on this thread or do we switch to another one? Based on certain decisions. One of them is time. How long has this thread been running? Has it been running long enough, or is it time to use up its time and go on to another thread? Let's try what happens with preempt tick. Preempt tick calls, hey, if it's time, it calls reschedule, resched cur lazy, which means reschedule the current thread. Reschedule means bump it off and go to somebody else. And it says lazy. I'm going to make a stretch of imagination and say that it's lazy because this task has had too much time. Now, there's other reasons why you might preempt a task, but that's particularly one of them. Now, what happens then? Well, let's see. reschedule current lazy calls this thing called set TSK, which stands for task, and set task need reschedule lazy. Okay? It sets a flag. That's that switch that I was talking about in the other video. And then what happens to set task need reschedule calls something else. Set task thread flag. Once we set that flag, something's going to happen. And something's going to happen whenever we get out of the interrupt. Now, that's where my brain falls apart. I can't quite find the exit functions. Now, what do I mean exit? Well, remember, this whole process, the whole process of interrupts is accept an interrupt, save some registers so that those registers can be used by the next thread if necessary, go off, do your junk. This is not what the application is. That's what the operating system is providing for you. Then you come back and you restore those registers, and also you check to see if you're done or not. Now, if that flag is set, you're not ready to totally return yet. You've got to do something called switch context, meaning when I return from that interrupt, we're going to come back into a different thread. We won't be where we were before. And that is the switch. That's task scheduling when you switch from one to the other. But as you can see, it ain't easy. It ain't easy. So, what I'm going to do is do the boring part and go through the code files. So, if you don't like code files, probably not, and you want to just turn this darn thing off, that's fine with me. But I'm going to present the code, the source code from Linux. Here we go with the code. If you're still here, let me make a comment about comments. I got some feedback that people usually don't comment on YouTube's because the author doesn't respond. I guarantee I'll respond in a day or less. Every morning I get up and check for comments and go, oh, I hope I get some comments. If they're negative comments, that probably helps me more than the positive comments. So please comment. I love comments and I will respond to those comments. From the interrupt chain from the clock periodic, we call tick handle periodic. Then we call tick periodic, which we'll look at the details very quickly to see what tick periodic calls. Here's tick periodic. Tick periodic calls update process times. Update process times, which I'll go to in a little bit, is in another file called timer. Update process times deals with the timing of the operation, and it calls scheduler tick. Scheduler tick is in the core file. Scheduler tick then calls scheduled clock tick. This is the runtime queue lock. This is update runtime queue clock. Where is the magic thing I'm looking for? I'm looking for something that is this is the thing that's hard to find. Here it is. This is what I missed on my first look at all this. Notice it says current, which is the current task, scheduler class. And the scheduler class, if you go into the scheduler class, you'll find out that task tick is actually defined as task tick fair. So our next thing is we go to the file called fair to see where task tick is. Now notice all I'm doing is just proving what I already said. Nothing new is being pointed out here, just showing you the code in case you want to look it up in your own time with the downloaded source files from the Linux site or some source. What I did is actually did them from the Red Hat site, but that's because I'm in Oracle Linux. Finally found the correct function in fair.c. Now remember, fair.c comes from completely fair scheduling, which is one type and the most popular type in Linux. Task tick fair comes down here and calls something which is odd, and that is entity tick. As I mentioned before, I'm not quite sure why it's called entity tick, but it says for each scheduled entity, and what I'm thinking is each entity is, if you have multi-cores, then you have multiple entities that you have to keep track of. Ooh, that's complicated. Multiple cores. I haven't talked about multiple cores. Entity tick says update current task. That's the completely fair scheduling run queue. And then we would ensure the runnable average is periodically updated. And then we should call something which is check preempt tick to see if it's time for us to try something else. Here's where we're getting close to switching tasks if it's necessary. Check preempt tick will hopefully get us closer to changing the tasks. It says when many tasks blow up the scheduling period, it is possible that schedule slice reports unusually large results, which many tasks are very light, for example, therefore impose a maximum. So it's trying to set things up properly so we don't reschedule when we're really not ready to do so. In this case, I want to go down the reschedule route, so I'm going to look for reschedule current lazy. Still in scheduling fair or fair.c, so we're getting close to setting the flag that I promised earlier. Let's find out where we actually do that. We need to go to core.c to find the definition of resched current lazy. Reschedule current lazy. Down here, there's various conditionals. One says actually reschedule current. And let's see, where's the magic thing? Da, 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 da. Set task need resched lazy. This is defined in a header file of all things because it's a really short function. Often, really short functions are described in header files. So let me copy that number there or that text area and come up to here and oh, it's already highlighted. Set task need reschedule lazy. And then that says, now we're getting down to brass tacks. Set task thread flag to TIF. What is TIF? I don't know. Need reschedule lazy. So let's see where set task thread flag is defined. And I bet it's defined in this file. So let me see if I'm right. Let me go up there, set task thread flag. Where is it defined? That's still calling it. It's not defined there. Here we go. Set tasks thread flag says, is that flag? Yes, it is. Set tasks thread flag says set TI thread flag, and then it tells you what the flag is and so on. So it's getting a little bit deeper. Why does it go this deep? I'm not sure. That's very curious. Let's highlight that little thing and see if I can change the setting on my search. Set TI thread flag. Let's see where that goes. I don't see it defined here. Okay, that must be somewhere else. Hi, I guess I added myself in the screen here, which maybe adds a little flavor to it anyway, so that you know that I'm a real person. Set TI thread flag is defined here. Then talk about low level, set bit. You know what? I think I've done a long enough of this. I don't need to do find set bit because that's just, well, it's getting boring, to be honest. And this flag is going to be comprehended enough in the exit routine from the interrupt. So, probably going to take another whole video just to describe the full interrupt request process from clock interrupt to saving the registers to leaving all this stuff that we've already done and then get down to the point where we get back out and reschedule and go to a context switch and we do a schedule and then we do all that other stuff. So that is more than enough for this one. So again, comment. Even if you just say wow or dumb or I don't care about this or just get something off your chest, write in the comment and I'll respond and we'll start a little conversation.